Good morning. This is the second problem on balancing of rotating masses. Here we have a problem. It is similar to the previous problem, whatever we have solved in the last class. But the number of masses are different here. But in the previous problem, we had only 4 mass, but here we have 5 masses. The problem is like this: 5 masses M1, M2, M3, and M4, and M5. There are 5 masses revolve in the same plane. The plane of rotation is same as the previous problem, because all 5 masses are rotating in the same plane. Magnitudes of M1, M2, and M3 are only 3 masses are given: 5 kg, 2.5 kg, and 4 kg respectively. Angular positions of M2, M3, and M4 and M5 are 60 degree, 135 degree, 210 degrees, and 270 degrees from M1. Here the masses, or the angular position of masses M2, M3, M4, and M5 with respect to M1 is 60 degree, 135 degree, 210 degree, and 270 degree. Here the reference mass is M1. All the angles will be taken from M1. So that's why you need to take M1 along positive x-axis, 0 degree angle. With respect to that, we need to consider all other masses. Now, last sentence, determine the masses M4 and M5. You need to find out the value of M4 and M5. Angles of all the masses are given. The magnitude of M1, M2, and M3 is given, but M4 and M5, magnitudes of M4 and M5 is not given in the problem. That we need to find out. So first step, we are going to consider the masses. Here, the radius of any mass is not given in the problem. Radius of rotation of any mass, M1, M2, M3, M4, and M5 are not given in the problem. So let us say this is the one more difference. The first difference, we have 5 masses. The second difference, 3 masses are given, 2 masses are unknown. Third difference, radius is not given in the problem. Radius is not given in the problem. So that's why. So this is somewhat different from the previous problem, but the method of solving the problem is same as the previous one. Let us go to the given data. So given data is like this. Yeah, given data. Let us consider. Okay, given data. Okay, first one, M1 is given. M1 is equal to 5 kgs. M2 is given. M2 is equal to 2.5 kgs. And M3 is equal to 4 kgs. But M4 is unknown. M5 is also unknown. And the corresponding radiuses are not given in the problem. If you consider the different radius for different masses, then you cannot solve the problem, because everything will be unknown. In the tabular column, every values will be unknown, so you cannot solve the problem. That's why, for assumption, if the radius is not given, please make a note. Radius is not given, then you need to consider, or you need to assume radius of rotation is equal to R1 is equal to R2 is equal to R3 is equal to R4 is equal to R5. Means all radius are equal and it is equal to R. We are going to consider the radius of rotation. If it is not given in the problem, That's why you need to assume radius of rotation is equal to R1 is equal to R2 is equal to R3 is equal to R4 is equal to R5 is equal to R. This is one more important point. Next, if you come to the angles, your angular position of M2 with respect to M1, angle of M2 with respect to M1 is equal to 60 degree. Similarly, angle of M3 with respect to M1 is equal to 135 degrees. Angle of M4 with respect to M1 is equal to 210 degrees. Last one, M5 with respect to M1 is equal to 270 degrees. This much data is given in the problem. Angles are given. Radius we have assumed because it is not given in the problem. We have assumed as equal radius as R. M1, M2, M3 is given. M4 and M5 is unknown. So this is the problem. Now, the first step, we need to draw the space diagram. The space diagram, with the help of angle, you can draw the space diagram. Let us go to the space diagram. Yeah, step 1. Step 1, space diagram. Space diagram. To draw the space diagram, first we need to draw a horizontal line. Because it is a single plane, you can draw a line on the reference line. Let us consider the color as the reference line. Okay, see, this is the reference line. Let us take the starting point as somewhere here, because we'll draw the side view first. If the masses are rotating in a single plane, you consider the side view first. So first one, the mass M1 is a reference mass. Reference mass is always this is O. So this is the reference mass M1. We need to draw it along zero line, that is positive x. Positive x is this line, positive x, right side. So M1 is in the positive x axis. So this is the line, and this is the circle, and this is M1. What is the value of M1? M1 is 5 kg. Next, the corresponding radius is R. We have considered it as R. Next one, M2. M2 is inclined at an angle of, see, this is M2. M2 is 2.5 kg, but M2 with respect to M1 is 60 degree. So draw a line at an angle of 60 degree from O. This is M2 at an angle of 60 degree. So here, this is M2 and it is equal to 2.5 kg. But what is the angle? Angle is 60 degree. 60 degree. So radius is R. Same. Next is third mass M3. M3 is 4 kg, but it is M3 is inclined to M1 as 135 degree. 135 degree. So take 135 degree from M1 0. So 135 will be somewhere here. Will be somewhere here. Measure the angle by compass. Sorry, protractor. So this is 135. 135. 135. So this is 135. Draw a line or a circle indicating the mass. M3 is equal to 4 kg, and the corresponding angle is 135 degrees. See, this is 135. 135 degrees, and the corresponding radius is r. Next, M4 and M5, the magnitudes are not given, but we know the angle. First one, M4 is inclined at an angle of 210 degrees. Measure 210 degree from the reference. From which reference? From this line, M1, because all the angles we have taken from M1. With respect to M1, M4, mass 4 is inclined at an angle of 210 degree with M1. So we need to measure from M1. M1, so this is the horizontal line up to here. This is 180 degree. 210 means plus 30. You need to measure 30 degree here. Total will be 210. 30 degree means somewhere here. See, this is 30 degree. So now we have to show the mass here. This is, and this is unknown mass, and the angle is, this is M4. This is M4, and it is unknown. Radius is R. The corresponding angle is known angle, that is 210 degrees. Next one, the last one, M5, but M4 is unknown. That's why it's better to shade it like this. This is unknown. Angle is known, but it is unknown. Mass is unknown. So the next thing is M5. M5 also, we know the angle, but we don't know the magnitude. So that's why let us go to M5. Angle is 270. 270 means 210 plus 60 degree. 60 degree means, I think it is exactly vertical. 270. 270 vertical line below, because 210 up to here, 270 plus 60 degree. So it is vertical. Exactly vertical. Or yeah, see, this is vertical line. Now this is a circle. M5 is unknown, radius is r, but the corresponding angle is 270 270 degree. 270 degree. So this is also unknown mass. Just shade it. Otherwise, you can shade with a dotted line or a red colored line. Side view. The side view is over. We have marked M1, M2, M3, M4, M5 with respect to the reference mass M1. 60 degree, 135 degree, 210 degree, 270 degree. Angle should be measured with actual angle. It is not a freehand sketch. It is measured, proper angle and drawn. Next is the side view. If you want to draw the side view, you can draw. Otherwise, you can leave it. No problem. Nobody will ask you, because it is uh, a type of problem which is rotating on a single plane. So if you want to draw, you can draw, no problem. So I'm going to draw the shaft. And this indicates a shaft. and we need to draw a vertical line. It indicates axis because, or a plane of rotation. A plane of rotation is there. So the first mass is m1. M1 is here. M1. M2 is somewhere here. This is M2. And M3 is somewhere here. You just project it from the side view. This is M3. M4 somewhere here. M4 is shaded because unknown. This is M4. M5 is the last mass. Shaded one because it is unknown. M5. So this is the front view. After this space diagram, let us go to the next step, step 2. It is a tabular column. Tabular column. Step 2. Tabular column. Okay, to find out the centrifugal force, we need to draw the tabular column. Here, all the masses are rotating in a single plane. That's why the tabular column will have three columns. Three columns. Let us draw a tabular column with the three columns. First, for the heading. Second, okay. So first column for the mass, second column for the radius, third column for the centrifugal force. Only three columns because it is a type of problem where you can see the masses in a single plane. The masses in a single plane. First one, mass kg, and next one is a radius column, radius in meter. Third one, centrifugal force divided by omega square r, because r is equal for all the masses. That's why we need to divide, because r is unknown. That's why we need to divide it by r, because centrifugal force is equal to F into omega square into r. This omega square is common for all the masses. R is also common for all the masses. So centrifugal force, so F, centrifugal force divided by omega square into R. There is no change in that because omega square and R is common for all. So mass M1, let us take M1 is equal to 5 kg, M2 is equal to 2.5 kg, M3 is equal to 4 kg, M4 is unknown, and M5 is also unknown. Similarly, radius are all radius are equal. That is R. We have assumed it as same R. So that's why centrifugal force is equal to equation for centrifugal force is equal to F into M into omega square into R. So this omega square and R is common for all five masses. So that's why divide the centrifugal force by omega square into R. So otherwise, if you are not dividing this omega square and R, because R is unknown and omega square is unknown, so we'll get the unknown values in the last column. So to make it unknown values, we need to divide this by each and every value. So centrifugal force is equal to M1 into R into omega square, M1 into R into omega square divided by omega square by R. That will be 5. Remains as it is, 2.5 omega square by divided by omega square into R. This is 4. This is M4 remains as it is. Last one is also M5 remains as it is. So this is the table. After writing the tabular column, here we have a last column. We need to see the last column. Last column is very, very important, where you can see the centrifugal force. This is the centrifugal force. Yeah, there are 5 centrifugal forces. In these 5 centrifugal forces, we have only 3 knowns and 2 unknowns. 3 knowns and 2 unknowns. But we know the angle of all 5 centrifugal forces. All 5 centrifugal forces, we know the force polygon. You know, for static balancing, summation of all the forces, centrifugal forces, must be equal to 0. Or you can say like this. So that's why we need to draw the force polygon. That is step 3. Step 3. Step 3, force polygon. This is very, very important step, force polygon. Only half of the problem I have completed till the tabular column. The next half is a force polygon. Force polygon, you need to consider the proper scale. If you go to the previous table, here we have 5, 2.5, and 4. The maximum value is 5. So you can go for 1:1 scale. 1 centimeter is equal to 1 kg of force. Yes, 1 kg of force. Scale, consider the proper scale. Therefore, scale is equal to 1:1, or 1 centimeter is equal to 1 kgf force, because the last column of the centrifugal force is kgf. So let us start from the beginning. We have mass 1, that is m1. The centrifugal force is 5. 1:1 scale, it is 5 centimeter. But what is the angle of m1? It is 0. It is 0. So let us draw. Let us start from a 0 point. Let us start from here. This is the point O. Start 0. And you need to draw a line, a reference line. From here, reference line is nothing but 0-degree line. This is the 0-degree line. Just draw a reference line. So this is the reference line where the reference line is here. This is the reference line, 0-degree line. Once you click on the reference line, or draw the reference line, now we need to measure the angle of M1. Angle of M1 is 0. 0 means it is on the line. But what is the length of M1? That is, force value is 5. 5 Newton, 1:1 scale. It is 5 centimeter. Draw 5 centimeter line. This is 5 centimeter line. After drawing the 5 centimeter line, you need to mark the point. This point is A, and the length of the line is 5 Newton or 5 kg. So this is the starting point and this is the end point. Next, you need to draw a reference line from point A. From point A, reference line is always 0-degree. Reference line is 0-degree line. Just draw a line. It is a very thin line of any length, 2 or 3 centimeter, no problem. It indicates it's a reference line. After that, you need to do the second one, that is mass 2, M2. The force due to mass 2 is 2.5 kg. 2.5 kg, F means 2.5 centimeter, 1:1 scale, 2.5 centimeter. But the angle of M2, what is the angle of M2? Angle of M2 is 60-degree. Measure 60-degree from the reference line. From this small blue line, you need to measure 60-degree. Measure 60-degree and draw a line. 60-degree and draw a line. Now, what is the length of the line? It is 2.5 centimeter. 60-degree and 2.5 centimeter. This is 2.5 centimeter. Yeah, 2.5 centimeter. Mark the point. This point is B, point B. Now, what is the corresponding angle? Angle is 60 degree. So this is point B. Now point B. Now again you need to draw a reference line. Reference line. The reference line is from point B. It is like this. It is 0 degree line. It should be always horizontal. Please make a note. It is always horizontal line. Now M3, the value of force is 4 kg. 4 kg means it will be 4 centimeter. But the angle of M3 is 135 degree from the reference line. Measure 135 degree from here. 135 degree from here and length as 4 centimeter. 135 degrees. 135 degrees. So 135 degrees somewhere here. Yeah, 135 degree. The point is here. This point, the length is 4 centimeter. 4 centimeter means this is 2.5 centimeter. Here it is 4 centimeter. 4 centimeter. The corresponding angle is 135 degree from the reference line. 135 degree. After this, you need to draw a next line. This point is point C. Let us consider this point is C. Now again, you need to draw the reference line. Reference line as 0 line, positive x-axis. After this, you need to mark the next line. Next is M4. It is unknown. You cannot take the length, but you can measure the angle. Angle is given. Angle is 270. I think it is not 270. It is 235. Sorry, 210. 210 degree. Measure 210 degree here. Measure 210 degree here. 210 degree. Yeah, we have measured 210 degree. Just draw a line. We don't know the length of the line. That's why you need to just draw the line. You need to draw the line. I'm going to draw it like this. I don't know the length of the line, so I'll just draw the line. A long line. Because I cannot cut the length. Length is unknown. M4 is given. That it is unknown. Just draw a line, a long line. And it is unknown. That's why you just make it dotted. Okay. This is unknown. Next is you need to take the fifth mass. Fifth mass is M5 unknown and the angle is 270. Angle is 270. So angle is 270. From where you're going to take? You need to draw the reference line, blue line. Where you're going to draw because we don't know the point here. The length of the line is unknown. So that's why we don't have the point, end of the edge. We don't know. So you cannot take this angle 270. How do you take this angle? Let us assume the point is somewhere here. The point is somewhere here. Somewhere here. Let us assume the point is somewhere here. So if you draw a line that is 270, I think this is the reference line. This is the reference line. If you assume, let us assume the point is somewhere here. This is the reference line. You're going to measure 270 here. So this will be vertical line. 270, if you measure 270, it is vertical line and it will meet at this point. To complete the force polygon, this point has to reach to this point, not here. So that's why, let us assume this point itself is this one. Here, this is 90 degree. So instead of taking 270 here, it's better to take 90 degree on this point. So that automatically the other point will have 270 degree. So better to take 270-degree. Instead of 270-degree, you take 90-degree here and draw a line. So this is the point or a line. It is 90-degree. 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 How it is 90-degree? 270 minus 180. That is 90-degree. Next is you can erase this part, not a problem. So we have a point of intersection of these two dotted lines. This is dotted line because it is unknown mass. So two dotted lines are intersecting at a point. That point itself is point number D. This point is D. So you can erase the remaining thing. This is not necessary because we have marked somewhere here. It is not exactly that. That is assumption. You can erase this assumption line. Okay. So erase it and mark it as D. D, and the reference line or a horizontal line somewhere here. If you measure the angle, this angle is automatically 270. If you measure it, you'll get 270 exactly because we have taken 90-degree here. Automatically, that angle will be 270. So this is very, very important. This step. So the people will do up to here 270-degree. Will take a long line and joining of the fourth edges will be complicated. So please make sure that it is to be taken 90-degree here and then join. You'll get the intersection point D and you can measure the angle that will be always 270. Now this mass is the length of CD is M4. Length of CD is M4 and length of OD is M5. M5. Now the calculation. So M4 is equal to from post polygon figure M4 is equal to length of CD into scale. So length of CD into scale, it is equal to, if you measure the length of CD is equal to 4 centimeter. You're getting 4 centimeter into scale is 1:1, 1/1. Will get M4 is equal to 4 kg. Similarly, M5, if you want to find out the value of M5 is equal to length of OD into scale. It is equal to length of OD. I'm getting 3 centimeter into scale 1/1. Will get the answer as 3 kg for M5. So this is the calculation. What question he has asked to find out M4 and M5. We are getting the answer for M4 and M5. So the fourth polygon must be closed. That's why we have closed. We have reached to point O after drawing all the edges. This is a pentagon because 5 masses are there. It's not a pentagon. It is a polygon with 5 edges. So that's why last point should be on O. That's why we have taken last point 90-degree and drawn a vertical line, that is a dotted line that will intersect another dotted line. So that point is a D. So thank you.